This problem will look at finding the domain and range of a function, but try to focus more on the algebraic aspect of finding those. So to begin with, we'll do domain. This is a function where there is a fraction and the variable for input for domain appears in the denominator. So where we'll focus on should be all numbers except what makes the denominator 0, because we don't have any square roots here. So we need all numbers except what makes 2x plus 8 in the denominator equal to 0. So if we set 2x plus 8 equal to 0, you get 2x equals negative 8, which gives you x equals negative 4. So negative 4 is the only number that would create an issue in that denominator, because that would create division by zeros. So the domain answer here would be all real x values except negative 4. All right, so that's how you'd answer domain. For range, again, you could graph it to verify, but if you want to think about it algebraically, the range of the original function is going to be the same thing as the domain of the inverse of this function. So if we can find, and again, it's not questioning whether or not the function has an inverse, but if you find an algebraic representation of the function, of the inverse of the function, then we can look at what restrictions there are on that. So if I take the function x minus 2 over 2x plus 8 and I solve for x, I'm not going to interchange anything right now because I would actually like it in terms of y so that I can apply that to range for my original function. So if I solve that, you'll end up multiplying, let's see, both sides by 2x plus 8. So you have 2xy plus 8y equals just the x minus 2. Then if you're trying to solve for x, so we need to get the x terms on the same side of the equation. So I'm going to subtract over the x and also right the 8y term because it doesn't have an x in it. I'm going to factor out an x, so I have 2y minus 1 equals negative 8y minus 2. And then if I divide both sides by 2y minus 1, this is an algebraic representation of, again, this is an f inverse function in terms of y, but it's an inverse for the original function. And if I look at its domain, I'm restricted here with all y values except 1/2. 1/2, if I do 2y minus 1 equals 0, 2y equals 1, 1/2 creates 0 in this denominator. So for this function, the domain, again, this is the domain of the inverse function. The domain of that function is all y values except negative 1/2. I'm sorry, positive 1/2. So the way that equates to the range is the domain of the inverse is the same thing as the range of the function. So algebraically, I can answer that the range of my original function is all y values except 1/2. And you can see this on the graph should you choose to graph it. You have it's a rational function, so at negative 4 there is this split, but you also have the fact that it does, let me go to the calculator, it does this split at negative 4 vertically because x can't equal negative 4, but horizontally it does pop above the y-axis, and you can sort of see that here. So it's not exactly everything but 0, but it's actually everything except 1/2, and you can try to trace the points as you go along. If I can get them to trace, here we go, like 0.42, 0.43, 0.44, 0.4. You can keep going on forever to infinity on the x-axis, or negative infinity, but it will never quite reach 0.5. So you can visualize and verify it, but algebraically you can go through and look at the range being the domain of the inverse function, and you can get your answer that way.